Okay, good morning, guys. We're going to go over the comets, asteroids, and meteoroids outline. So, excuse me. So if you can go ahead and make sure you're looking at that. I'm going to start with the comets. So I've got an infographic up here that kind of goes over all of the different ones. Actually, I'm on the wrong one. Here we go. There we go. So we're going to start with the comets, which are out here. So a comet, its origin, where did it come from? There's two places that comets have come from, the Oort cloud and the Kuiper belt. Kuiper belt. Now, scientists actually don't have any physical proof about the Oort cloud, but they do have some images of the Kuiper belt. They're both located outside of our what you would consider our solar system, so they're out past Pluto. But it's just an outer rim where a lot of the comets are located, and that's where the Kuiper belt is, and the Oort cloud would be out further from the Kuiper belt. So the idea behind that is that's with the belt, that just happens to be where most of the comets in our solar system are located. Just a bunch of ice and dust and rocks, put together, and then they're orbiting the sun. The Oort cloud is thought to be even further out from the Kuiper belt, and like I said, we don't have any actual proof because that's where they think that very few, if any, comets have come from there. It's like less than, I think, 2% of the comets have, scientists think, come from this Oort cloud, which is this random cloud of rocks and dust and ice and things just kind of floating. They actually don't have orbits out there, but the comets inside of the Kuiper belt do. So the size of your comets is going to range from a couple of meters across to several kilometers. So a couple of meters to several kilometers across. Composition, what it's made out of. Like I said, hopefully you X'd out the 1, 2, and 3 underneath composition, because there's more. But some of the common things that your comets are made out of are going to be ice, dust, rock, water, some methane and nitrogen, ammonia, and carbon dioxide. So ice, dust, rock, water, and then some gases would be methane, nitrogen, ammonia, and carbon dioxide. The interesting thing about these, and it kind of jumps down to letter E, the appearance as it approaches the sun. You've got a body of the comet, which if you look at this diagram here, it's going to be that circular part here. That's where the majority of your solid part of your comet is going to be. So the ice and the dust and the rock is all going to be there. It's going to, as it's moving through the solar system, so as it's coming towards the sun here, all of that solid stuff is going to sublimate. And if you remember back in chemistry, sublimate means going from the solid phase straight into the gas phase. It's going to pass through the liquid phase. It's not even going to become liquid. It's just going to go straight from being a solid to a gas, kind of like when you open up a freezer door, you see all that gas coming out. It's the ice from your freezer sublimating into the gas. So that's basically what's happening as your comet is moving throughout the solar system, is all of that ice, dust, and rock is going to sublimate, and it's going to get turned into those gases of methane, nitrogen, ammonia, and carbon dioxide, which would make up this part back here, which is the tail of the comet. So with your orbit, we're going to go ahead and say that they do orbit the sun. I know I said that some of the comets that come from the Oort cloud don't technically have an orbit at that point, but since most of the comets come from the Kuiper belt, those do have orbits, we're going to say that a comet does in fact have an orbit. So letter E, this picture right here is showing you how the comet appears as it gets towards the sun. You typically think of comets coming and you think of them as having the body here and the tail going like this. And you're right, except it's only doing that as it's coming towards the sun. Okay? As it gets closer to the sun, the tail turns and faces away from the sun. The tail will never face towards the sun. So the tail isn't going to keep coming here, and then right here, you can see how the tail comes away. So the tail doesn't stay in the one place and come off this way. It's going to actually move and face away from the sun. So it's kind of weird, but as the comet moves away, the sublimation and all the gases is actually going to be in front of the comet. So the appearance as the comet approaches the sun, the ice and the dust is going to sublimate, so you see that tail, but the tail is always going to face away from the sun. So you want to make sure you know that in a comet, the tail always points away from the sun. Okay, we're going to move on to asteroids. With asteroids, the origin of an asteroid, they came about when the solar system formed. So they were formed when the solar system was formed. Scientists believe that they're basically just leftover remnants or pieces, leftover parts from when the solar system started. The size of the asteroids, they're going to be anywhere from 6 meters to 940 kilometers large. Some of the larger asteroids are now being classified as dwarf planets, and if you look at this picture here, you can see that one of them actually is. It's called Ceres. It's actually one of the larger asteroids that we've classified as an asteroid before. So the composition of your asteroids is going to be rocks, silicon, nickel, iron, oxygen, and magnesium. So rock, silicon, nickel, iron, oxygen, magnesium. Lots of elements. They're going to be in various amounts too, just depending on the asteroid itself. These do have an orbit. They're going to orbit around the sun just like the planets, and they're going to follow that elliptical orbit, so that slightly oval orbit. And here I want you to note also that they are located between Mars and Jupiter. Most of you know this, but if you don't, your asteroid belt is all of the asteroids are going to be located between Mars and Jupiter in the thing called the asteroid belt. So in this diagram, it also shows you the Kuiper belt, so you can kind of get an idea from the comets from the last one. So like I said, it's outside of our solar system, what we consider our solar system. So some of the Kuiper belt objects aren't going to be comets, but most of our comets do come from the Kuiper belt. Okay, if you flip your page over, we're going to head on to meteoroids. Okay. Excuse me. A meteoroid. They were formed, so the origin, they were formed, most of them are going to be formed from the collision of asteroids. Very few of them are going to be formed from the collision of an asteroid hitting a planet or a moon. Most of them are going to be formed from just asteroids hitting each other and breaking off into smaller pieces. So, okay. Moving on to the size of the meteoroids. Sometimes they are, I don't think it's set on there, but sometimes they can be as small on your resources, sorry. As far as I know, it's not on there, I don't think. So, meteoroids are going to be significantly smaller than your asteroids since they were formed from the collision of asteroids. So we're going to say they can be as small as a meter. They could be as large as 20 kilometers. They might be a little bit bigger than 20 kilometers, but they're significantly smaller than your asteroids. The composition of a meteoroid is going to be rock, iron, silicates, oxygen, and nickel. So rock, iron, silicates, oxygen, and nickel. Silicates are going to be, it's not silicone, but it's versions of silicone, usually bonded with oxygen. The orbit, they don't always orbit the sun, but sometimes they will orbit the sun. So with this one, sometimes they have an orbit, sometimes they don't. If they were a part of a comet, so sometimes the parts of the comet can detach as they're going through, and then as they're sublimating, they can have pieces of the comet break off. And then in that case, they would have an orbit. Sometimes if they're collisions of asteroids and they don't knock the remnants completely out from the asteroid belt, then yes, they would have an orbit. However, sometimes they don't have orbits because they can fall into Earth's atmosphere. So going down to letter E, other forms. That's what this diagram here is for, to help you. If it's they're all basically the same thing. A meteoroid, a meteor, and a meteorite, they're basically the same thing. The difference is its location. If it is out in space, it is a meteoroid. So in this instance, this particular meteoroid would not technically have an orbit because it's coming towards Earth. It's not going around the sun at that point. If it enters Earth's atmosphere, it's going to be a meteor. So the definition of a meteor is a meteoroid that is passing through Earth's atmosphere. So a meteor is a meteoroid that is passing through Earth's atmosphere. As it comes through Earth's atmosphere, it heats up and kind of burns up, which is why you get the tail-looking structures at the end of a meteor. You probably have heard of a meteor called a shooting star. If you've heard of another name, I guess I should say, if you've heard of another name that a meteor would go by, it would be a shooting star. So you might have heard of meteor showers. That's when perhaps a larger meteoroid is passing through and is breaking apart into smaller pieces all at once, and so you're getting lots of smaller meteors passing through the atmosphere, and that's going to appear as a meteor shower. So you're going to be able to see those. All right, the second thing under a meteor, how it differs from a comet. A comet is sublimating. Remember, it's going from being a solid to a gas. So it's kind of like melting, but it's not passing through the liquid stage. A meteor is not sublimating. It's burning up. That's why you see the tail. It's not going through a phase change. It's essentially being vaporized. It's burning. I guess I shouldn't say vaporized. It's burning. So it's going through a chemical change. And since the comet is sublimating, that would be a physical change. Okay. The last one, meteorite, down here. Once the meteor has passed through the atmosphere and hits Earth, once it hits Earth, it is now considered a meteorite. So the definition of a meteorite is it's a meteor that has hit the Earth. Or you could say it's a meteoroid that has hit the Earth. You would technically not be incorrect if you said either one, meteoroid hitting Earth or meteor hitting Earth. The other thing to note about a meteorite is that when they hit the Earth, sometimes they leave behind those indentions known as craters. They don't always, but the larger ones do. So make sure that you have updated this outline because you will be responsible for this information. Okay. The next thing, depending on how much time you have, if you have enough time, you're going to need to, on the back side of your chart, the what do you know chart that we filled out yesterday, there's a Venn diagram. It's a triple Venn diagram. On this Venn diagram, there are 3 circles labeled asteroids, comets, and meteors. Probably should say meteors / meteoroids. But you need to fill out this Venn diagram. And remember, the individual circle that's not overlapped by another one, those are characteristics unique to that particular celestial body. So in the right circle, you're going to be filling out characteristics that are unique just to the meteors and the meteoroids. Where it overlaps, like in the middle there between comets and meteors, that one place where you can see the overlapping of those 2 circles, you need to find at least one commonality between the 2. And then you've got that triangle looking thing there in the center. You need to come up with at least one commonality that all 3 of these have in common. If you look on the PowerPoint that I attached to the Google Classroom assignment, I have very specific instructions for your Venn diagram for the unique characteristics for asteroids, comets, and meteoroids / meteors. So make sure that you are looking, because you need to include for each of the 3 celestial bodies, you need to tell me how, you need to look up, and we haven't gone over it, but you need to look up, no, I guess we have, sorry. You need to give me the size and composition. You need to tell me the location, how they're formed, if they follow an orbit, and if they do, tell me what they orbit, if they go by another name, and then do they enter Earth's atmosphere, and then 3 other characteristics. This is what you might have to look up. Okay? So I want 3 other unique characteristics for each one. So you're gonna have to ask the sub as to whether or not this is going to be homework, because it's going to determine, number 1, how much time you have left in the hour, and number 2, how well you're working. So if you do have questions, just email me. I will be on later tonight on Google Hangouts if you have any questions. So over this. So I'll be on at 7 So if you do have a question, you can log on and I'll try to answer those for you, or you can just email me. Like I said, I'll check it at about 7 o'clock tonight. So if you need to stop and rewind anything or go back and listen to something, you can do that. If not, depending on how much time you've got, you probably want to start getting started on that Venn diagram. So hope you guys have a good day, and I'll see you tomorrow.